Okay, this is Derek Thompson, and I'm going to do the rest of the examples from 2-1. I'm going to start with 23, which some of you got to. And what they wanted was, I really just care about part A. They give you a big function here, 5x over 1 plus x squared. And they want you to find f prime of 2 and use that to find the equation to the tangent line. And they say to the curve y equals instead of f of x equals. That's the same thing, they're just switching notation. And I guess they say at the point 2, 2. So I guess they already give you the fact that the function value, the f of 2, is 2. So this point here says that if x is 2, then f of 2 is 2. So to get f prime of 2, I'm going to use the first definition of derivative. So it's x approaches 2, and then f of x minus f of a, which is 2, over x minus a, which is 2. So f of x is the actual function here, 5x for 1 plus x squared. And f of 2 was given to be 2. And so now, just like anytime I'm working with a complex fraction, I'm going to make that big numerator a fraction, and then I'll make the bottom a fraction, so I can multiply by the reciprocal. So this needs to be multiplied by 1 plus x squared over 1 plus x squared. So this is... A couple of you asked me about if you have to write limit every time, and you do, because a limit is not the same thing as an equation. When a limit exists, it's just a value, and all the canceling and things that I'm doing, that changes a function. If I cancel an expression, that makes it go from one function to another, but the limits stay the same. So I'm just going to combine that top there. And I'm a bit out of space, so I'll go to the next page. But notice here, I have to subtract 2, and I have to subtract 2x squared. Right there. So that is an important point, which you'll see in my next slide. So this will be 5x minus 2 minus 2x squared over 1 plus x squared all over x minus 2. And this is the limit as x goes to 2. Now, nothing factors in that top, but there's no common monomial to factor out. So I'm going to factor out a negative because it's going to make it easier to do the factorization. So I'm going to write negative, and I'm going to reorder these. 2x squared minus 5x plus 2. Because it's a lot easier to factor doing reverse FOIL without a negative there. So now that numerator factors, I'll just kind of point to the side here. I have the minus, but then it's going to factor as 2x minus 1 times x minus 2. So that's going to be that numerator. So now let's get a clean sheet here. This is going to be minus 2x minus 1 times x minus 2 over 1 plus x squared. And that's all over x minus 2, and I take the limit as x goes to 2. So that denominator, x minus 2, I'm going to call that x minus 2 over 1, so that way I can just multiply by the reciprocal, because I have two fractions now. Now I can cancel the x minus 2's. So now, after that, I can plug in 2, because that was really the issue. So it's minus 4 minus 1 over 1 plus 2 squared. And that ends up being minus 3 over 5. And that is the slope. The point was 2, 2. So the equation of the tangent line is just y minus 2 equals minus 3/5 x minus 2. There's a part B where they tell you to graph it on a graphing calculator, but since we're not going to be using those on our test, I'm just going to skip that. Okay, so that was 23. The next problem assigned was 27, and 27 is going to take a little bit of work. 27, they want you to find f prime of a in general. So I'm not going to give you a specific value. This is like the example for the polynomial I did, or the velocity problem that I did about dropping a ball from a tower on Thursday. So the function, they're going to use t instead of x, so we just changed all the x's to t in the definition. This is f of t is 2t, let me be more clear, t plus 1 over, so 2t plus 1 over t plus 3. So I want to use the definition that f prime of a is the limit as t approaches a of f of t minus f of a over t minus a. I'm just replacing x with t. It's the same definition. So, and I'm just doing it at a general a. So that definition, let me get a clean sheet here. F of t is just the function that I wrote, 2t plus 1 over t plus 3, and then minus plugging in a. So if I plug in a, it's just 2a plus 1 over a plus 3. And that's all over t minus a. So I do the same work where I try to combine the fractions, but I need to do common denominator, and so that's going to be t plus 3 over times a plus 3. So this one needs a t plus 3 over t plus 3. This one needs an a plus 3 over an a plus 3. So now I'm going to FOIL those individually, but remember when I FOIL the right, I'm going to have to subtract all of that. So I've got 2at plus a plus 6t plus 3 minus all of 2at plus t plus 6a plus 3. That's all over t plus 3 over a plus 3. And that's all over t minus a. So it's a bit of a bear. However, a lot of things are going to work out nicely here. When I do that subtraction, you're going to see that 2 ATs will cancel. And what else cancels here? The plus 3 and the minus 3. So the top then, if I can fit it here, it's going to be 6t plus a minus t minus 6a over t plus 3 times a plus 3. And let's go ahead and write times 1 over t minus a just to save some room so we don't have such a big fraction. So dividing by t minus a is multiplying by 1 over t minus a. And now we can see that we can combine still the numerator on the left. We can combine 6t minus t, and we can combine a minus 6a. So that's going to be 5t minus 5a over t plus 3, a plus 3, times 1 over t minus a. I'm going to take the limit as t goes to a. So if I factor a 5 from that left numerator, that's 5 times t minus a, which is what we're trying to get rid of. I can finally cancel that factor. And now I can substitute a in for t, which means that this will be 5 over a plus 3 times a plus 3, or a plus 3 squared. So now that's a formula for f prime of a, and no matter what x value I decide a is, I can use this formula to find the slope at that point for the whole graph. That's the advantage of doing it generically. So that was 27. And if you haven't noticed, I assigned a lot of blue questions, which are the tougher ones, so that's why that one's a bit more involved. 32 here. The 32 is something else, and they're going to write a limit, and they're going to say this represents the derivative of some function at a number a, and they want you to know f and a. So here, you can tell by the limit notation that they're having h go to 0 that they're talking about the second definition, f of x plus h, or f of a plus h. So it's the fourth root of 16 plus h minus 2. And so the function, well, looks to me like it would be the fourth root of x, because I have this fourth root function, and on the right, that should be when I plug in 16. Because the fourth root of 16 is 2, and that's how they got 2 on the side. That would make f of a 2. And that's how they got this expression. And if I put a plus h in for x, that's how you would get this, if I put in 16 plus h. So this is kind of a reverse engineer problem where you have to figure out where they got the expression. And so the answer would be that's f of x and that's a. So I'll give you another example of that kind of problem. Here's 34. And this is the limit as x goes to pi over 4. And the fact that it's not h going to 0 means we're using the first definition. And this is tan x minus 1 over x minus pi over 4. First off, x in this definition, x goes to a, so it's pretty clear that a is pi over 4. And the top is supposed to be f of x minus f of a. So f of x should just be tan x, and that makes sense because f of pi over 4, which would be f of a, tangent of pi over 4 is 1. So this looks pretty good. So it's actually a little easier to do with this definition. So this would be the answer here for 34. Now 37 is a story problem, but I'll just read it to you. A warm can of soda is placed in a cold refrigerator. Sketch the graph of the temperature of the soda as a function of time. Is the initial rate of change of temperature greater or less than the rate of change after an hour? So the trick here, if this is time and this is temperature, so I'll use big T, is that sure it starts out warm. So we'll say some higher temperature here. I'm just going to sketch the idea. And it does get cold, but if you put it in a fridge, the can doesn't freeze, right? Because then it would explode, like when you put a pop in a freezer. It lowers temperature, but eventually the temperature doesn't change at all. Because if you put a can in the fridge and you check 6 hours later and then you check the next day, it's the same temperature. So eventually you get to the point where the temperature is no longer changing. So what you can see here is that the initial slope, the initial rate of change of the temperature, is greater, even though it's negative, so I'm talking about in steepness. If I can draw this line correctly. Here we go. That's much steeper than maybe an hour later. It's going like that. So the answer would be yes, the initial rate of change is greater. Even though they're both negative slopes, it's a bigger difference to start. And I would be more clear on a question whether I'm talking about the absolute value or the sign, because technically the first number is a lower value. For example, if this was minus 5 and this was minus 1 in slope, minus 5 is less than minus 1, but this question is asking about the steepness, and minus 5 is a steeper slope. So that was 37. 43 another story problem. Let me see if I can get this picture here. So here is 43. And they say the cost of producing X ounces of gold from a new gold mine is C instead of Y, but it's a function of X, so we write F of X, dollars. What is the meaning of the derivative F prime of X? What are its units? Well, F prime, that's the rate of change, right? So the way that's going to work, let's just go to the next page. So we have C equals F of X, and this is normally X is in ounces, and C is in dollars. That's the value in gold. So the derivative is basically for at a certain amount of ounces that you've produced, what is the cost of producing a bit more? Because tangent lines, that's kind of the local slope. So if you think about maybe the cost looks like this, then the slope means, the slope, for example, here, means that to get that many more, to go that farther than X, to get that many more ounces of gold out is going to cost you that many more dollars to go to the next ounce. So another way to think about derivatives is how much is the marginal cost to go to the next amount. And so the next part of the question is, what does F of 800 equals 17 mean? That means that if you're at 800 ounces that you've got out of the gold mine, it's going to cost you about $17 to get the 801st ounce. So this means it's about $17 to get the 800, 17 more dollars, I should say, to get the 801st ounce. So you can just think about it in terms of the next one. And so the marginal cost here, that's the cost of the next one up. It's how much more, right? It's how much of an increase. And so the F prime's units, I didn't mention that in the first one, but F prime of X, the units are dollars per ounce. So you just divide the units you had before. You had dollars and ounces. Now it's dollars per ounce. And that's the rate of how much more it's going to cost each time. Maybe to start, you only had to pay $1 per ounce because you're at the top of the gold mine, but now that you've dug a bunch of gold already, maybe the price is going up. And that's part C. It says, do you think the values of F prime of X will increase or decrease in the short term? What about the long term? I would say that in the long term, once the mine is mostly empty, you're going to have higher costs to get the next ounce of gold out. Short term is a different question here. And in the short term, it's your initial cost. You have to get tools and everything, but once you have all the tools set up and you've got the first ounce, the next few ounces are going to be cheaper because you've already got your system going, you've got your workers going and everything. So it'll decrease in the short term and increase in the long term. So maybe a better graph would be something like you have a high initial cost and it decreases, but then long term the expenses go up. Okay, that is 43. Last one I want to talk about is 49. And 49, they want to know if f prime of 0 exists. And so this is a point to make because I want to see about the fact that derivatives don't always exist. And so this is a function that we use the squeeze theorem and show that a function had a limit at 0. And so that limit was 0. Or at least it seemed like it should be 0. And the function's not defined at 0, but we're going to define it piecewise and say, well, at 0, we're going to just call it 0. So I'm just going to use my limit definition and try to figure out if f prime of 0 exists, right? And so that's the limit as x goes to 0 of f of x minus f of 0 over x minus 0. Well, f of x, you're taking x near 0, right, when you take a limit, not at 0. So I can just write x sine 1 over x. But then f of 0 is defined to be 0 because of the second part of the piecewise function, and the denominator is just x. So now we have x sine 1 over x, and those x's will now cancel. But we know that the limit as x goes to 0 of sine of 1 over x does not exist. This is one of the first examples we did. So even though we used the piecewise function to kind of plug the hole, because the function had a limit there, the derivative does not exist there. So the derivative does not always make sense. And I'll give you another example of where a derivative does not exist. It's a bit simpler, just to reinforce this point. If you take absolute value x, and you want to take the limit, or maybe not say the limit, but just say f prime of 0, that does not exist. And the reason why is because on each side of the graph we have this V shape, and on one side the slope is 1, and the other side the slope is minus 1. And so the slopes are different on each side, so they're not converging to a limit. If I came to a limit from the right of the slopes, it would be 1, and if I came to a limit of the slopes from the left, it would be minus 1. And so because those don't agree, it's not clear what the, even though maybe you think it should be 0, it's not clear what the derivative should be at 0. So the derivative there does not exist, and that's because those limits don't make sense. Alright, so that's everything from 2.1.